Data collected by James Webb shows something disturbing about the universe. Something is wrong with the timeline of the universe. Not slightly wrong, not a small adjustment waiting to be corrected. Something deeper, something that doesn't fit. Because when scientists pointed the James Webb Space Telescope into the darkest regions of space, they expected to see the early universe as it should have been. Simple, chaotic, still forming. Instead, they found something disturbingly mature. Galaxies that should not exist yet. Structures that appear too organized, too massive, too evolved for their place in time. It's as if the universe skipped steps, as if it moved faster than the laws we believed governed its birth. For decades, we've trusted a cosmic story. A story that begins with a sudden expansion, followed by slow formation, gradual structure, predictable evolution. A story built carefully, tested repeatedly, refined with precision. But now, the light arriving from the deepest past is telling a different version. And here's the unsettling part. This is not speculation. This is data. Real observations. Signals that traveled for billions of years just to reach us, carrying a message we are only beginning to understand. So, the question is no longer whether we've discovered something new. The question is, what if we've misunderstood everything that came before? Because when the universe reveals something unexpected, it doesn't just give us answers. It forces us to confront the limits of what we thought we knew. And what we are seeing now may be the beginning of that confrontation. The cosmic disturbance. The universe may have formed too fast. That is not a poetic exaggeration. It is a growing suspicion. Because when we look back into the earliest moments after the beginning of everything, we are not supposed to find complexity. We are not supposed to find fully shaped galaxies, structured systems, or anything resembling maturity. The early universe should be a place of beginnings, not conclusions. And yet, that is exactly what is appearing. Light from more than 13 billion years ago is revealing galaxies that already seem complete. Not fragments, not seeds, but systems that look like they've had time to evolve, to organize, to become something stable. And this creates a tension that cannot be ignored, because if these galaxies exist at that point in time, then something in our understanding is off. Either they formed much faster than our models allow, or the timeline itself is not what we think it is. There is no comfortable middle ground here. This is not about finding something unusual. Science expects surprises. What it does not expect is to find patterns that consistently refuse to fit. And that is what makes this disturbing. Not the existence of these galaxies, but the implication that they may be telling us something fundamental is missing. Something about the way the universe began. Something about how structure emerges from chaos. Something about time itself. And if that's true, then we are not just observing the universe. We are witnessing the first signs that our understanding of it may be incomplete. What we were certain about. Before these images arrived, before this tension began to grow, there was a quiet confidence in the way we understood the universe. It was not blind belief. It was something stronger, a structure built over decades, supported by observation, mathematics, and repeated confirmation. A story that explained how everything came to be, step by step, from simplicity to complexity. In this story, the universe begins in an event we call the Big Bang. Not an explosion in space, but an expansion of space itself. From that moment, the universe is hot, dense, and almost uniform. There are no galaxies, no stars, no structure, only a vast, nearly featureless sea of energy. Then, slowly, almost imperceptibly, tiny fluctuations begin to grow. Gravity starts to pull matter together. Clouds form. The first stars ignite. They live. They die. They forge heavier elements. Over hundreds of millions of years, galaxies begin to emerge. Not fully formed, but assembling, merging, evolving. Complexity is not immediate. It is earned through time. This timeline became more than a theory. It became a foundation. Every observation we made seemed to reinforce it. The cosmic microwave background matched predictions. The distribution of galaxies aligned with simulations. The expansion of the universe followed expected patterns. Everything pointed in the same direction, like pieces of a puzzle locking into place. And because of that, we trusted it. We trusted that the early universe was simple, that structure required time, that nothing complex could appear too soon. These were not assumptions. They were conclusions drawn from everything we had seen, but that trust is exactly what makes this moment so unsettling. Because when a model works this well, when it explains so much with such precision, you don't expect it to be challenged at its core. You expect refinement, minor adjustments, small corrections. You do not expect to look deeper into the past and find something that doesn't belong there at all. And yet, that is exactly what is happening, which raises a question that is becoming harder to ignore. If the foundation is solid, why are the new observations beginning to crack it? The eye that looks back in time. To understand why this discovery feels so unsettling, you need to understand the instrument that made it possible. The James Webb Space Telescope is not just another telescope orbiting far above Earth. It is something far more precise, far more sensitive, and in a very real sense, far more patient. Because Webb does not simply observe distant objects, it observes time itself. Light does not arrive instantly, it travels, and the farther it comes from, the older it is. When you look at a galaxy billions of light years away, you are not seeing it as it is now. You are seeing it as it was billions of years ago, when that light first began its journey. This means that Webb is not looking into space, it is looking into the past. But here is where it becomes even more extraordinary. As the universe expands, light stretches. Its wavelength grows longer, shifting from visible light into the infrared. And this is where Webb excels. It was designed to detect that ancient, stretched light with unprecedented clarity, capturing signals that older telescopes simply could not see. In other words, Webb is tuned to hear the oldest whispers of the cosmos. It is capable of observing the first moments when structure began to emerge, the era when the universe was supposed to be young, unstable, still forming its identity. And for the first time, we are not guessing what that era looked like. We are seeing it, not through simulations, not through indirect measurements, but through actual light that has traveled across billions of years, carrying with it a record of what truly existed at that time. This is what makes Webb different. It does not interpret the past, it reveals it. And when that revelation does not match what we expected, the problem is no longer about theory. It becomes something deeper. Because if the universe remembers something different than what we predicted, then the issue is not with the observation. It is with our understanding. The discovery that shouldn't exist. When the first deep field images from the James Webb Space Telescope were analyzed, the expectation was clear. We would see the beginnings of galaxies, small, irregular, chaotic, structures still struggling to form, still gathering matter, still far from anything stable. That is what the early universe was supposed to look like. But that is not what appeared. Instead, astronomers began to notice galaxies that looked finished, not in the distant, mature universe we see closer to our present time, but in epochs so early that, according to our models, these systems should barely exist at all. And yet, there they were, massive, bright, structured, some of them containing more stars than should have been possible in such a short cosmic window. This is where the tension becomes impossible to ignore, because forming a galaxy is not a simple process. It requires time. Matter must collapse under gravity. Stars must ignite. Generations of stars must live and die to enrich the environment. Structure must emerge gradually, shaped by interactions and mergers. It is a slow unfolding. And yet, what Webb is showing suggests something very different. It suggests that somehow this process may have accelerated. That galaxies did not patiently evolve into complexity, but reached it far earlier than expected, as if the universe was already ahead of schedule, already building structures long before it should have been capable of doing so. This is not just surprising, it is deeply uncomfortable. Because if these galaxies are real, and the data continues to confirm that they are, then we are left with a difficult conclusion. It's not just that we found something new, it's that we found it too soon. And when something appears before it is supposed to, it forces a reconsideration of everything that led up to it. Either our understanding of how galaxies form is incomplete, or the early universe itself behaved in ways we have not yet begun to understand. And both possibilities lead to the same unsettling place. We are no longer just discovering the universe. We are discovering that it may not follow the story we believed it was telling. The timeline breaks. There is a silent rule embedded in everything we thought we understood about the universe. Time builds structure, not instantly, not abruptly, but gradually, through processes that require patience. Gravity pulls matter together, stars ignite, galaxies assemble piece by piece. Complexity is something that emerges slowly, like a story unfolding across billions of years. This rule has never been questioned in any serious way, until now. Because what the James Webb Space Telescope is revealing does not simply challenge details, it challenges timing itself. If galaxies this massive, this bright, and this organized already existed so early, then the sequence we trusted begins to lose its coherence. There is not enough time. That is the problem no equation can easily resolve. There is not enough time for matter to collapse at that scale, not enough time for stars to form in such abundance, not enough time for these systems to evolve into what we are now observing. And yet, they are there, which leaves us with a disturbing possibility. The timeline is not behaving the way we thought it did. This is where the discomfort deepens, because time is not just another variable in cosmology. It is the framework that holds everything together. Every model, every prediction, every simulation depends on the assumption that events unfold in a certain order, at a certain pace. But if that pace is wrong, then the entire structure begins to shift. What if the early universe was not slower, but faster? What if processes we believed required hundreds of millions of years happened in a fraction of that time? Or, more unsettling still, what if the sequence itself is incomplete? Because when observations begin to suggest that something happened before it was supposed to happen, the issue is no longer about speed. It becomes about causality, about whether the chain of events we trust is actually the one that occurred. And if that chain is broken, even slightly, then what we are facing is not just a revision. It is a rethinking of how the universe unfolds, not in theory, but in reality. The silent crisis in cosmology. There is no alarm ringing in the scientific community, no headlines declaring that everything is broken, no sudden abandonment of the models that have guided our understanding for decades. On the surface, everything appears calm. But beneath that calm, something has shifted. Because when data from the James Webb Space Telescope continues to reveal patterns that resist explanation, scientists do not panic. They pause. They question. They begin to look again, not at the universe first, but at their own assumptions. This is how science responds to tension, not with rejection, but with quiet pressure, with debates that unfold in papers, in conferences, in conversations that rarely reach the public eye. And right now, those conversations are becoming more intense. Some researchers suggest that these early galaxies may not be as massive as they appear, that perhaps the way we interpret their light is leading us to overestimate their size. Others propose that star formation in the early universe could have been far more efficient than we imagined, allowing structure to emerge more rapidly. These are not desperate explanations. They are careful attempts to preserve a framework that has worked remarkably well. But there is another layer to this, because not all scientists are convinced that small adjustments will be enough. Some are beginning to consider that the issue may not lie in isolated parameters, but in the foundations themselves. That perhaps the way we model the early universe, the behavior of matter, or even the influence of unseen components like dark matter may require deeper revision. And this is where the tension becomes real, not visible to the public, but present in the way questions are being asked. Because when multiple explanations are proposed and none of them fully resolve the discrepancy, it creates a space of uncertainty, a space where the known and the unknown begin to overlap. This is the silent crisis. Not a collapse of knowledge, but a moment where knowledge becomes aware of its own limits. And in that awareness, something important begins to happen. The possibility that the universe is not just revealing new information, but inviting us to rethink the very framework through which we interpret it. Possibilities we were not ready for. When the known explanations begin to stretch, the mind does something instinctive. It reaches beyond what is comfortable, not to abandon reason, but to explore its edges. Because if the observations are real, and the timeline truly does not align, then the question is no longer just how galaxies formed. The question becomes what else might be happening beneath the surface of what we can see. One possibility is that the early universe behaved differently than we expected, not in a small way, but in a fundamental one. That the conditions shortly after the Big Bang allowed matter to collapse faster, more efficiently, forming stars and galaxies at a rate we have not yet fully understood. A universe that did not hesitate, but accelerated into structure. Another possibility is that something invisible played a larger role. We already know that most of the universe is not made of the matter we can see. Dark matter, something we have never directly observed, shapes the gravitational scaffolding of the cosmos. But what if its behavior in the early universe was not what we assume today? What if it clumped differently, interacted differently, created conditions that allowed galaxies to emerge earlier than expected? Then there is a more unsettling idea. What if our models of cosmic evolution are incomplete, not wrong in their entirety, but missing key elements? Processes we have not yet discovered, interactions we have not yet measured, mechanisms that only become visible when we look far enough back in time, and Webb has taken us exactly to that point. But there is an even deeper question, one that sits quietly beneath all the others. What if the universe did not start from a state as simple as we believed? What if the early cosmos already contained structure, already held complexity in ways we are only beginning to detect? This idea is not a conclusion, it is a question. And it is the kind of question that does not come easily, because it asks us to step beyond the boundaries of what feels established, to consider that the universe may not just be revealing new details, but new possibilities. Possibilities that challenge not only what we know, but how we think about knowing itself. What if the universe is older or stranger? At some point, every scientific question reaches a boundary, a place where the answers we have are no longer enough, and the questions begin to change their shape. Because if the timeline does not align, if galaxies appear before they should, if structure emerges faster than expected, then we are left with a possibility that feels difficult to approach. What if the universe is not unfolding the way we think it is? Not simply faster, not just more efficient, but fundamentally different. There are models still on the edges of mainstream discussion that suggest something unusual about time itself, that the early universe may not have experienced time in the same way we perceive it now, that the rate at which processes unfolded could have been altered by conditions we do not yet fully understand. And if that is true, then the phrase "too early" may not even mean what we think it means. But there is another possibility, one that goes even further. What if the universe is older than we believe? Not older in the sense of a small correction, not a matter of millions or even billions of years added to the timeline, but older in a way that reshapes the origin itself. That what we call the beginning may not be the absolute beginning, but a transition from something that came before. This idea has been explored before, cautiously, often at the edges of cosmology. But now, for the first time, observations are beginning to push in a direction where such questions can no longer be dismissed as purely speculative. Because when the James Webb Space Telescope shows us galaxies that seem too evolved for their time, it forces us to consider whether our reference point for time is correct at all. And then there is the most unsettling thought of all. What if the universe is not just older, but stranger? Stranger in the sense that its rules are not fixed in the way we imagine, that the laws governing its earliest moments may not fully match the laws we observe today. That reality, at its deepest level, may be more flexible, more dynamic, more complex than our current models can describe. This is not a conclusion. It is a threshold, a moment where the universe is no longer just something we observe from a distance, but something that challenges the way we define existence itself. And standing at that threshold, we are left with a realization that is both humbling and profound. We may not be as close to understanding the universe as we thought. The human limit. There is a quiet truth that follows every great discovery. The more we learn, the more we become aware of how much remains beyond our reach. For centuries, we have extended our senses through instruments. We have built machines that see deeper, measure finer, calculate faster. With each new tool, the universe has revealed more of itself, as if slowly allowing us to step further into its vastness. And yet, there is always a boundary. Not a physical edge in space, but a limit in understanding. Because everything we know about the cosmos is filtered through interpretation, through models, equations, assumptions that attempt to translate reality into something we can grasp. We do not see the universe directly. We see what our methods allow us to reconstruct. The James Webb Space Telescope has extended that reach farther than ever before. It has brought us closer to the earliest moments of existence than any instrument in history. But even now, even with this extraordinary clarity, we are still interpreting, still trying to align what we observe with frameworks built from previous knowledge. And this is where humility enters the picture. Because when observations begin to resist explanation, it is not a failure of science. It is a reminder of its nature. Science is not a collection of final answers. It is a process, a continuous refinement of understanding, shaped by new evidence, guided by curiosity, and constrained by the limits of perception. And those limits matter. They remind us that the universe does not owe us simplicity. It does not adapt itself to fit our expectations. It unfolds according to principles we are still uncovering, in ways that may not always be intuitive or even fully accessible to us. So, when we encounter something that does not fit, something that challenges the structure we have built, we are faced with a choice: to resist it or to learn from it. Because the history of discovery has always followed the same pattern: moments of certainty followed by moments of disruption. And it is within those disruptions that understanding evolves, not by confirming what we already believe, but by revealing where we are incomplete. The universe looks back. At the beginning of this journey, there was a simple idea: that something in the universe did not fit. Not a small inconsistency, not a detail waiting to be corrected, but a signal. A quiet indication that the story we have been telling ourselves may be incomplete. Now, after looking deeper, after following the light across billions of years, that signal feels different. It feels intentional. Because what the James Webb Space Telescope has revealed is not just a collection of distant galaxies. It is a reflection of our limits, a reminder that the more precisely we observe, the more clearly we begin to see the edges of our understanding. And in that realization, something shifts. We often imagine that we are observing the universe from a distance, that we are separate from it, studying it as something external, something to be decoded piece by piece until nothing remains unknown. But what if that is not the full picture? What if, in the act of observing, we are also being confronted, not by intention, not by design, but by the sheer complexity of a reality that does not simplify itself for our sake? Because every time we look deeper, every time we refine our instruments, every time we think we are getting closer to the beginning, the universe responds with something unexpected. Not answers, questions. Questions that reach further than the ones before. Questions that do not just expand our knowledge, but reshape it. And this is where the disturbance becomes something else. Not a problem to be solved, but an invitation to continue, to question more deeply, to accept that understanding is not a destination, but a path that extends beyond what we can currently see. Because the deeper we look into the universe, the more we begin to realize something profound. It may not have been waiting for us to understand it, and yet, somehow, it allows us to try.